Hi everyone. For those that don't know me, my name is Ken Kim. I'm a former electrical engineer turned automation sales guy. Just wanted to make a quick brief video. I know there's a lot of talk about different types of automation. I want to just make this video just so more people can understand just various concepts. So I'm going to be using things like my phone, for example, to explain. So I want to talk about AI, Industry 4.0, and 3D printing and different styles of robotics, and as I've done that before for different customers at my job in the past. And so I think we'll first off start off with Industry 4.0. So you heard the term IoT 4.0 versus maybe like IIoT 4.0. So essentially what IoT stands for is the Internet of Things. And I think better way to visualize it is imagine as like the internet of people, where you have, say, like an interface like your phone is able to communicate with like all sorts of different networks. For example, your phone has all these apps over here, and each app is communicating with a different network. And so with that one interface to your phone, which is called an edge device, you're able to do a lot of things to make things more space efficient. And as a result of this, it just makes things a lot cleaner. And so that's a good example of IoT 4.0, where you just have one device that's able to communicate with different networks throughout. And IIoT 4.0 is essentially just that, but except on a more industrial setting. So for example, a manufacturing floor where you may have different PLCs, HMIs, robotics, machines on the factory floor that in the past were not able to communicate with one another just because they all have different languages manufactured in different countries. So it gets very difficult with, especially with the firewalls, IT networks, for them all to communicate with each other. But in recent times with IIoT 4.0, it's been able to have that capability, and many people are concerned regarding hackers, that sort of agenda. But the thing about it is a lot of these IoT 4.0 monitors actually do have SQL networks, where even if you are able to hack into the system, they'll have like a certain code where you won't actually see like all the reference points. You're just gonna see a bunch of numbers. So that's just the difference between IoT 4.0 versus IIoT 4.0. You hear about AI, artificial intelligence, very much so now in the media. I want to explain to you there are some differences in between how some companies may market artificial intelligence. For example, I'm going to use my phone again. Say this camera right here has artificial intelligence. Some AI will actually not be true AI in the sense that it'll use more pattern recognition. And what I mean by that is, say like the camera with the AI is able to take a picture and then takes another picture. It has a picture of those positions, but then, so the camera is using pattern recognition where it's able to know that picture every single time. But then, say you move the camera again, the camera doesn't have true AI in the sense that you would have to program it again just for it to learn. And so you're gonna have to constantly reprogram. And in that concept, that's kind of how pattern recognition works, where you kind of have to keep reprogramming to essentially learn all these different scenarios. A more in-depth real version of AI would be like you take a few pictures and the AI has deep learning capabilities where it can take a few pictures, let's say like a quality inspection, and then from those pictures alone, it could actually use deep learning neural networks to actually self-learn, and you don't have to keep reprogramming it. And that's sort of like a more in-depth version of AI that's coming more frequently now in the last few years. In terms of robotics, so a lot of people hear about robotics in the sense that, people have the fear that robotics are going to take jobs, but there's still a lot of capabilities that robotics still cannot do. For example, it's very hard for a robotic to move in certain aspects. For example, you have collaborative robots that can work in a close proximity to a human, but then there's very limited on speed. They're very limited on what can be on the end of the arm. And there's a lot of other very factors, because if you're using a collaborative robot and you put something dangerous on the end of the robot arm, it becomes not collaborative anymore. Or, for example, you have an autonomous mobile robot that's supposed to be self-driving, yet the thing about it is there's still a lot of unknown variables sometimes that can pop up. Say, for example, like the self-driving cars, you have something that just pops up. The car still has to kind of account for that. So like there's still a lot of defects, improvements that have to be made in that regard. Versus the traditional robots that are used, like the traditional 6-axis robots or the linear gantry style robots that move up and down. Those are still relatively used just because, we still are kind of testing out humanoid robots, but the reality situation is humanoid robots are still going to have a lot of speed limitations just because of how hard it is for a robot to move from a mechanical standpoint. It's not going to be anywhere close to on par with humans for the time being. And finally, I want to just talk about 3D printing. A lot of people have probably seen like the 3D printed homes, the 3D printed all sorts of different types of components, but there's still a lot of limitations with even 3D printing. For example, when you're 3D printing a component, a lot of times it actually takes a lot more time versus the traditional manufacturing, like say like CNC machining, which is essentially subtractive manufacturing. And subtractive manufacturing is essentially where you take a component and you're pretty much using like a drill or something to like just take off layers, and so you have a block and then you're making it the shape. The exact opposite would be additive manufacturing with just 3D printing, where you're just continuously adding layers. But a lot of 3D printers, what they essentially do is they use a laser, a heat guided laser, to 3D print each row, each round. But the problem with that is if you try to speed up that process, then because you're using a heat guided laser, it can actually make a part defective very easily. And the only way you can really speed up that process if you somehow find a way to change the law of physics, which is not going to happen anytime soon. So even though 3D printing is a very neat idea, it's still not got a long ways to go for it to like truly start replacing the different types of subtractive and other types of manufacturing processes that we have now. If you have any more questions, please feel free to reach out. Thank you.